All right. Lesson 37, equations and graphs of trigonometric functions. All right, so most of this is going to be a review of really lesson 35. But the new aspect here is really just this. Typically, like when we've done other functions, you know, like log graphs and exponential functions, anything else, right? Quadratics. We can solve them different ways, right? So we could solve this thing, which we've worked on in the last section there. So let's say one like this: 4 sine theta minus 5 is equal to 3, right? We'd solve that. We could do that algebraically. But the other way to do that is graphically, right? So it's really the same idea. We can set this up so that we can graph the equation. So here, I'm going to write this out a little different. So we could write it out where, well, actually, there's lots of ways to solve this. We could do this where I could graph, not the whole thing, just the one side. Graph that as y1, graph that as y2, right? Or we could do a little algebra and get it looking a little nicer to begin with, which is what I'm going to do, right? I could write it like this. So if I started off with 4 sine theta minus 5 is equal to 3. I'm going to do a little bit of algebra. I'm going to add 5 to both sides. So I get 4 sine theta is equal to 8. And then divide by 4, divide by 4. So you get sine theta is equal to 2. This will be nicer, right? I'm gonna graph this as my y1 and this as my y2, right? That'll be kind of nicer to look at too. Or the other thing you could do, right, is you could get everything on the same side. It would also be true to do this and say, bring the 2 over, and we could have sine theta minus 2 is equal to 0. And then graph this as y1. And really, you don't have to graph this as y2 because that's just my x-axis, right? You could if you wanted to. It's just going to be a line along the x-axis. But either way, if you did it this way, I could just graph this one and then just find my x-intercepts, right? That'd be the same thing. So there's lots of different ways you can graph this and solve this. I'm going to do it this way, graph both of those. So I have the graphs on here again, but for the most part, you can sketch those out, but I think I'm just going to do it right on the site I'm using. It's called Desmos graphing calculator. It's kind of nice and easy, so I'm going to do it on here. So let's type in our first one. Our y1 is just sine theta, right? So you could do this on your graphing calculator, but you could type in, on this one you can go y is equal to sine theta or just sine x is what it would be, right? You can zoom in and everything else on this one. Okay, so there's that one. And then, oh, shoot, stuck to my mouse still. Okay, and then the second part of this would be the y2, right? So I'm going to graph y2. And if you just, on this one, if I just put in 2, it doesn't work. I do have to put in y is equal to 2, right? And there it is, the green line there, right? And just so you're aware, you could have went y is equal to sine. It'd be the same thing, right? But there you go. So what am I looking at here? Well, I got this line up top and I got, my sine function down below. And I'm asked, like, where is this true? Like, and really that's asking, where do they cross? They don't cross, right? So actually in this situation, the answer here would be no solution or does not exist. DNE is often how it's written, right? So kind of a funny first example, but there you go. All right, so let's do this one now. So we've got tan squared theta minus 3 tan theta is equal to 0. Okay, so I don't actually have to rearrange this at all. I could bring the 3 tan theta like over to this side and graph 2 of them, but really we can get away with just graphing that as my y1 and then looking for my x-intercepts, right? Because that you can do y2 if you like, but that really is just the x-axis, right? So I'm just going to graph this and figure out where it crosses the x-axis. So let's do that one. So I'm going to get rid of those. So we're going to have tan squared, and then you put it in as x in here. So x would look like that funny one. And then minus 3 tan, oh, that's not tan, tan x. And there you go. So there's our weird looking graph we got going on here. We're not going to try to figure out too much of like why it looks that way. Just we've got this and now it does. So just looking at our question here though, let's see what we're looking for. So it's saying, where is this true, right? So where does this cross the x-axis? And it's saying between, so when the angle is greater than 0 and when the angle is less than 4 pi. So just to get my bearings here, what I'm going to do, I'm going to change my x-axis grid to go up by pi. So now my grid goes up, you know, steps of pi there, right? And it says from 0 to 4 pi. So I can actually zoom out a little bit here. And I can see that it's all my answers here are going to be, well, this one, this one, this one, this one, right? Those are all my x values for those, or my answers for each of them, right? So I could write them all down. That would be true, but we like to write them a bit more mathy. So here, this is the way we're going to do it. We're going to say angle theta, so theta 1, will be equal to, and then it's going to be equal to, let's do this one first, because we can see if we just skip this middle one, right? You've got 0, and then you've got pi, and then you've got 2 pi, and then you've got 3 pi, and then you got 4 pi, right? And it's between those. And it says greater than or equal to 0, and then just less than 4 pi. So it doesn't actually include the 4 pi, right? So it'd be really those black dots there are going to be my answers for that one, right? So the way we're going to write that would be like this. We'd say it's going to be pi times n, where n is, oh, I'm going to write a little bit farther away. N is greater than or equal to 0, but less than 4. And then you'd also say where n is a member of the whole numbers. Okay, so what does that mean? So what we just said there is that we could put in 0 in for n, right? So 0 could be a number that we put in for n, and then that would give us an angle of 0. So that's this answer right here, right? That's our very beginning. We could put in the number of 1, right? So if I put in 1 in for n, then that'd be pi. Okay, well, there's that answer. I could put in 2, there's that answer. I could put in 3, there's that answer. I can't put in 4 because it says n has to be less than 4. Okay, so it excludes this one, right? Which we want. It doesn't also include 4 pi. And now n has to be a member of the whole numbers, right? So it's got to be like, 1, 2, 3, yada, yada, yada. 0, 1, 2, 3. That's it. Okay, so fancy way of saying all that, right? Okay, so that accounts for those numbers I'm looking at on the screen right now, right? All of those. So I'm going to click off of those now. Okay, so now the other part of this, we're going to say, like the other answer would be angle 2 would be, now this one's not as nice, right? You can kind of see where it crosses here is at 1.249 and then 4.39. Like it's kind of hard to even see the pattern here, but we actually do know that the pattern that's happening here, right? Because this one was happening in steps of pi every time it crossed. The distance between this one and this one is also going to be pi. You can check it out if you want. You could actually go this number, right? 4.391 minus 1.249. You should get 3.14 if you subtract those to figure out what the difference is between those. Okay, or what the space is between those. But either way, so it's going up in steps of pi, but it's starting at 1.25, right? It's starting at this 1.249 or 1.25, okay? And then from there, we're going to say plus, and then now it's going to be pi times n, where n, oh, sorry, where, we got to do the other part too, where n is greater than or equal to 0, because it could be 0 too, right? Because if I put a 0 in there, that just gives me this. okay, but less than 4. And then where n is a member of the whole numbers. All right, so hopefully that made sense. This isn't the only way that you could write this, by the way, too, but like there's a few different ones. But the biggest thing is you guys need to be able to like interpret this kind of thing when you see it, right? And you should be able to write it out too, but yeah, it's like a different language altogether, isn't it? Okay, so that's it. That's my solutions for this. Okay, if it would actually be a little bit easier, right? If it didn't have this restriction on it, right? Because then our answer would have just been, it wouldn't have had this part, and we could have said where n is a member of an integer, right? So it could have been negative numbers as well. All right, so moving on. So number 2 says write a sinusoidal function that models the average temperature in Brandon, Manitoba as given in the table. All right, so what are we looking at here? We got a bunch of months across the top, and we got a bunch of temperatures across the bottom. All right, so the months going across the top, those are going to be my x values, and the temperatures are going to be my y values. And what's going to happen here, to be an idea, is that we're going to get, the temperature going up, and then the temperature is going to go down, and then up, and then down, right? So we got a sine function or a cosine function, either one, a sinusoidal function. Okay, so let's get our bearings here. Now that we know it's going like up and down like that, I'm not going to get in, like, it's not going to look like this graph, like where it starts and everything, but that's generally how it's going to look. So I want it to be in this form. It's got to be, y is equal to a cos or sine. I'm going to do cos because I know what I'm, either, you could do either one, but I'll do cos. So b, and then x minus c plus d. Okay, so this is on your formula sheet, right? You guys have both of these. So really, if it wants us to write this out as a function, sinusoidal function, I got to figure out a, b, c, and d. Okay. Now, a, b, and d are pretty straightforward. We've got like little equations, if you will, for each of them. It's always this c value that's going to be the most difficult. So I would recommend finding your c value after. Okay. So let's do that. We'll find our a value first. Okay. So our a value is going to be, well, remember what the a value is. The a value is, it's our amplitude, right? Our a value is saying how high is this thing from here to here? And we had a little equation for that. That's not on your formula sheet, by the way. And that equation is, it's your max number, right? So your max number, like for your y value, minus your min number, right? So your smallest number, and then divided by 2. And that would give you your height up and down. Okay, so it's your max minus your min divided by 2. So let's figure out where that happens, right? So that's going to be, so remember the bottom numbers are our y values in this case. So our max value here, I'm looking for my biggest number. That's this one, 18.9, right? There's my max right there. And my min right there. Okay, so that's all we really needed for that. So I know that's going to be like the max would be like up here somewhere, min would be down there. Okay, ish, right? This isn't right, but that's the idea. So our max would be 18.9 minus, and then minus a negative, because you have to account for the negative there. So minus negative 18.3, which really becomes plus, divided by 2. So A is equal to, it ends up being 18.6. Okay, put a box around that because I'm going to need that in a second. All right, let's look now. Let's do the next one. Let's do D. D and A are kind of really similar, right? So, like to find them, I mean. Okay, so we'll find D now. And D, if I look back at my picture, remember what D was? D is our midline. D really is like how far up or down it's going. So let's say, like, I don't know if this thing's like above the x-axis, like above 0 or below 0. But in general, the way that you'd find this is really, I'm looking for the average between the top number and the bottom number, right? That's going to tell me what my mid number is, my midline. And that's really telling me how much the graph has been translated up or down, right? So the D is still the same thing. So anyway, let's find that average number. And instead of it being max minus min, it's going to be your max plus your min divided by 2. Like any other, like find the average of any two numbers, right? That would be the same thing. So same thing as before, but we're going to add them. So that's going to be our max, or sorry, I'm not going to write max again, 18.9, our maximum number, and then plus negative 18.3 divided by 2. Okay, and if you do that, you end up with D is equal to 0.3 degrees Celsius, right? So it's just a little bit above 0, okay, is where my midline is, okay? Okay, so we're getting there. I'm going to put a box around that. Next one, I'm going to find my B value. So B value relates to the period of the function. So this is a good one to know. B is equal to 2 pi over the period. Okay, so now what do we mean by period? Well, the period deals with our x values, right? Because our x values, if like on our graph here, it's going to be like 1, 2, 3, 4, 5, right? Like the months are going across the x-axis. So what would the period be here? Well, it's going to go up, it's going to go down, it's going to, or whatever, right? It's going to repeat the pattern after a year. So what's our period? Well, it's 1 year's worth of months. So that's going to be 12, right? 12 months. So if I want my B value, that's going to be 2 pi divided by 12. So our B value is pi over 6. All right, we got 3 of them, so we're good to go. Well, we're getting there. We're close. Now, the way I kind of recommend getting the C value, because actually this C value could be, well, really an infinite different numbers here. What I recommend is let's actually graph this thing without the C value, and then see what we have to do to actually turn it into this picture, into what we're looking at here. Okay, so if that didn't make sense, I'll show you on the graph here in a second. I think it'll make a bit more sense. So, right, we are going to write out this equation, right, but without the C. Okay, so I'll write it again. So we got y is equal to a cos b x minus c plus d. All right, we know 3 of those things, so we're just filling those in. So y is equal to, we said a was 18.6. Okay, cos, we said b was pi over 6. Okay, and then I'm going to leave this out for a second. I'm just going to leave that as x. Okay. Oh, shoot. Maybe I'll leave a little space there so we can write it in after, once we kind of get our bearings here. And then plus d, so d was plus 0.3. So like I said, I'm going to graph just this without any kind of c and see what I get. So let's go back over to my graph here now. And I'm going to type in y is equal to 18.6 cos, and then I'm going to need some brackets here. My b value is pi over 6. And then I'm going to start a bracket again so I can see the b there. And then x, I wouldn't really need to there, but either way. Now I'm going to skip to the outside there, right, outside the brackets, and then plus 0.3. So plus 0.3. All right, so this kind of makes sense, right? Like what I'm looking at here. This is kind of a standard cos graph, right? So remember, cos starts up at the top. If this would have been a sine graph, which we could have done, it would have started at the origin and went up, right? So that's the only difference between cos and sine. So ours is cos, so we started at the top. Now, if I look back at my data here, January, so when x was 1, says that y should be 18.3. Now, if I go to my graph, I can actually find your minimum there, like where that is, right? So I got 18, like negative 18.3. That's this number, right? We accounted for that. We did that with our A value, right? It figured our A and our D value, kind of figured all that out, right? For our minimums. But what's wrong here is the 6, right? So the graph I'm currently looking at says that at month 6, it would be negative 18.3. Okay, so I would actually really like that dot to be right there, right at 1. Oh, here, you know what I'm gonna do? I'm gonna change my axis there too, so it's not by pi. So instead of steps of pi, it'll be steps of 1, right, by default there. Okay, so either way, yeah. So if I'm looking at this one, 2 steps of 1. Huh. Either way, okay, anyway. So I'm at 6. 1 would be, you know, in here. That's where I'd like it to be, right? So I need to move this thing 5 to the left, right? So 5 to the left. So what do I got to do here? Well, that's going to be, so 5 to the left would be plus 5. And there you go. There's my equation, right? I could have done that for any of the points along the way, but it's kind of nice to find like a maximum or, you know, something like that, right? Now, why I was saying it could be like an infinite number of things that could go in for C there is because I could have also started right here, right? I could have said, well, 18. I could say, well, I'm going to move that thing 17 to the left. So this would also be true for me to say plus 17. Those graphs are the same graph, right? It's not changing anything. So, or here, there's another one. I could flip this thing upside down, right? I could say y is equal to negative 18.6 cos pi over 6, right? And then think about what that did. So x, leave that open for a second, plus 0.3. What that would do, right, the negative part of it, well, let's do it. If I threw a negative into that, it flips it upside down, right? Like you expect. It flips over the x-axis, so now I'm down there. Okay, well, what would I have to do now? So if I'm right here, it's supposed to be negative 18.3 at month 1. Well, it looks like I got to move this thing 1 to the right. So this would be minus 1. Okay, so those are all the same graph, right? So these two are exactly the same. So they're all the right answer at that point. So hopefully that makes sense. The C, like I said, the C part is always the toughest one. So as a recap, find your A, your D, and your B, graph it, and then figure out what you got to do to move it, to shift it, to phase shift it left and right. Okay, moving on here. Okay, number 3. The London Eye has a diameter of 122 meters, and it is 135 meters from the ground to the top. It takes 30 minutes for one rotation of the wheel. Passengers board at the bottom of the ride, and the wheel moves slowly enough that it is not necessary to stop to let passengers on or off. So it says, write a sinusoidal function to represent the height of a passenger riding the London Eye. Over what domain is the function valid? Okay, so Ferris wheels in math and in sine, in this sinusoidal function unit are very common. You guys are going to get lots of Ferris wheel questions. Okay, so here's what's going on, right? So we got a Ferris wheel. I'm right over here, so I got room. So you got a Ferris wheel. And let's write some numbers here, right? So we know that it said the diameter is 122. Okay, so what that means is that the radius would be 61. Okay, and I know that from the top of the ride, if this is ground level, the top of the ride to ground level here is going to be 135 meters. Okay, which means that if I go 135 minus 61, then from my ground level, which I'll call 0, this thing is up 74, right? 35 minus 61, so it's up 74. Okay, so my A value and my D value are staring me in the face now, because this graph, like once this thing starts spinning, right, it's going to spin around and around. If this was time going across this way, then your graph would be a sine graph, right? It's going to go, you know, up and then down and then up and then down. And my D value here is from the center of the graph. That's like my midpoint line, right? So that'd be my 74. It'd be like from there to there, right? And then my 61 would be my amplitude. My little sketch there is not to scale, by the way. Yeah, so that's the idea. So we can just kind of start filling those in now then. So I'll use cos again. We could use sine if we wanted to. So I'll say y is equal to, here, I'll just write the thing again. So a cosine b x minus c plus d. So our a value there was this, right? That's like going to be our amplitude. So 61. So 61. And well, actually, just a minute though. So a typical sine graph, or sorry, cosine graph starts at the top, right? We're starting at the bottom. So normally it comes around like this and goes like down and then up again. But we're starting at the bottom and we're going up because you're getting on at the bottom. So, you know, right off the bat, I'm actually going to make that negative. We'll call that negative 61, okay? Just to flip it upside down. So negative 61, and then cos, and then now b. So what's our b value? Well, sorry, I'm jumping around here a lot. B is equal to 2 pi over period. So our b value is going to be 2 pi, and then it tells us that our period, it takes 30 minutes for one full rotation. So 2 pi over 30. Okay, so divide those, 15, right? So we get b is equal to pi over 15. All right, so we'll fill that in. So we get b is equal to pi over 15 x. Again, like in the c is going to be a little bit funny, but actually for this one it's not, because it starts right at the bottom. I can assume that this thing starts right at the peak of this thing, and that's where a sine graph does start. So I don't have to shift this thing to the right or to the left at all. I'm good to go, right? So it's just going to stay as x. And then our d value was, well, that was this, right? That was our 74. There you go. There's our equation, okay? Now it says for what domain is the function valid? Well, we'll just assume that we have to start at time 0. So I'll say the domain would be x has to be greater than or equal to 0, where x is a member of the real numbers. Okay. Yeah, so that's pretty much it. So now B, how high above the ground would a passenger be after being on the ride for 1/3 of its duration? All right, so what is this saying? So like the duration for one full rotation, remember, was 30 minutes. And so 1/3 of that, you can probably do that in your head, that's 10 minutes, right? So divided by 3, so 10 minutes. So I want to know where this thing is at 10 minutes. So now, remember what we're looking at here, right? So this thing came up and down or whatever, right? Oh, actually, that's not right. Line to be down there. So it's saying how high is it? Well, that's our y value, right? And time is our x value. So it's saying at like 10 minutes, how high is it? So it's really saying when x is 10 or when t is 10, what is y? Okay, well, that's just throwing a number into our function. So that's all we got to do. We just got to throw 10 in for x and see what we get out. So if you do that, we would end up with, so let's say y is equal to negative 61 cosine pi over 15 and then 10, right? I'm going to multiply by 10 and then plus 74. Oops, 74. All right, so plugging that all in, you'd end up getting 104.5, right? So that's your height there, meters. Now, if you do this and you get the wrong answer, what the likely problem is you probably had your calculator in radians. In degrees. This has to be in radians. So radians. So make sure your calculator is in radians there. And why it's in radians and not degrees, because it could have been degrees, was at this point right here, when we found our B value, we said 2 pi over the period. If I wanted that to be in terms of degrees, I would have said 360 over period, right? 360 degrees. So it was at this point that I chose to be talking about radians instead of degrees, okay? So just make sure that your calculator is in the right mode when you put that in, because you get an answer, it just wouldn't be right. So just careful on that one. Okay, and then lastly, at what time would the rider be 100 meters above the ground? Okay, so what that's saying, so again, if I sketch this guy quickly, starts here and goes up and down, right? So at what time would it be 100 meters above the ground? That's saying this, right? So if you're 100 meters, let's say, is right here, and I drew a line across there, that's saying, when is this happening, right? Where is it crossing? Okay, so I'm going to graph these. What I'm going to do is I'm going to graph my function there, and I'm also going to graph y2 as 100, okay? So go back to my calculator here. So I'm going to type in y is equal to negative 61 cos pi over 15, start a bracket, and then x. And then we had to add 74, so then plus 74. So there's my graph. I'm only seeing the bottom of the one part here, right? So I kind of have to zoom out a bit. So there's my graph I'm looking at here, right? Now the second part here, I can even see, well, it's at 100. So it's like, where does it cross here? So I'm going to make one more graph one more function at y is equal to 100. Okay, so there we go. So now on your TI calculator, right, you'd have to find your intersection. So go to menu and intersection. But on here, I'm just going to click on them and I can see them, right? So that's kind of it. So it says, at what times would the rider be at that point? So that's going to be at 9.6 minutes for this one. And then at 20.4 minutes. But then if this thing kept going, I guess, yeah, we're saying one ride's 30 minutes, right? So we're not going to keep going on forever. So we're just going to say, so just these first two numbers. So your answer here would just be at 9.6 minutes. And 20.4 minutes. Okay. And that's it.